I can see you, so thank you for setting us up and thank you for tolerating the camera. Yeah, hi, welcome to From Gamepads to Launchpads, what the tech world can learn from video game UX. And as already so nicely introduced, my name is Theo. I am the Associate Game Director at snke Explore. I know in the description on the website it said Level X, which is semi-accurate. We went through a name change in the last couple of weeks and it's been chaotic, but we are now snke Explore, which is a subsection of snake OS, which is a company that aims to revolutionize data in the medical field. It's very weird and very techy and very interesting. My specific like subsection of Snake, which is snake Explore, we are video game developers that make video games largely for doctors, but recently turns out also for astronauts at NASA and SpaceX. So I'll talk a little bit about how that happened and how weird that is and why they chose that. I've been making video games for over a decade. Hard to believe, but yeah, that's what I do. And hopefully we can talk a little bit today about why we ended up making video games for astronauts, for the future of our space travel, and what NASA thinks about this and why. We are by far not the only one that works in that field with those folks. And then I'll talk a little bit about game design UX principles for your work and how it can apply to what you do. And then I want to kind of have a good chunk of time at the end where we play the game that we are developing right now, which is a continuation of all the other things, the one that flew to space and so on, from there. And I want to show you live in that game that we'll play together, how these principles apply in a real world scenario. Okay, so why the hell video games? I'd like to start with a quote from my now former CEO, Sam Glassenberg, who's a very interesting man to look up. I highly recommend it. His story is very interesting because he made Level X as a child of a doctor's family. Like all of his relatives are doctors, and he's like the black sheep of being like a tech guy among doctors, which is bizarre. And he was challenged by his dad to make a video game company to teach doctors how to do things. And he said, hold my beer, and here we are. So he made Level X, and he says this. There's a reason why tens of millions of Pokemon players can name 80 Pokemon, now more than that, but can't show you where France is on the map. It's because games are very good at education, and learning is an unintended consequence of play. I like this quote mostly because of the last part. I think video games are inherently about teaching people something, whether intended or unintended. Our games, of course, are a lot about the intention behind that, but fundamentally, all games that exist are in some shape or form about teaching you how to exist in the world within it. And what we know about humans is that they learn through play, fundamentally, and through meaning. And we have tried to harness that. So now I just want to give like a brief overview of the weird roadmap of how we got here and how we ended up with a game that flew to space and how we ended up with Artemis and all of that jazz, just so you understand. And I'll have videos of all that too in a moment. So just so you understand the roadmap a little bit, Polaris Dawn was the first project that I worked on, even though the company had been working with NASA for a little bit while before that. Polaris Dawn is actually a mission with SpaceX that flew very recently. It's a historical mission, very amazing. We made a short procedure guide companion game type thing to perform a very specific ultrasound procedure, which is called an IJV, internal jugular vein sweep on your neck, to collect data on zero gravity in the human body. It's less of a game and more of an interactive guide. And from there, we were then asked to make like a proper video game, which is called Artemis Ultrasound. We were funded by a side arm of NASA called TRISH and KBR, and I'll talk a little bit about that in a moment, which is currently in an efficacy study. I wish I had the results, but we're just like a little bit out from it, unfortunately. Science takes time. But that study is determining the usefulness of game-based learning for upcoming Artemis missions, and I'll talk a little bit about why that is important. And then in the end, we'll talk a little bit about Explore Ultrasound, which is what I'm working on right now, and the game that we'll play together, and which I will use to demonstrate these principles. Okay, so just a quick note. This is a bunch of pictures of us and me at the NASA Johnson Space Center. Super fun. We were there to go through the actual training that we were representing in the game ourselves. We talk a lot to doctors and to experts and to astronauts themselves too. One of the major challenges when it comes to learning anything for space missions is mostly that astronauts are very busy, maybe the most busy people on the planet, and their time, especially leading up to a mission, is very valuable. So a lot of people want to get all kinds of science done while they are up in space, and they're kind of like fighting for astronauts' time. And it can happen that, for example, with this ultrasound training, that astronauts get like 20 minutes of time in their years-long training, 6 months before they actually fly to space, to learn this procedure that they've never done before. And then when they are actually up in space, months later, they have to remember how to properly perform this and send accurate data back, which is complicated. Right now, we are solving this problem by having remote people, like basically dial into the ISS and do some remote guidance to make sure that this data is collected properly. But we don't really have that luxury when it comes to our more ambitious missions to the moon and to Mars, where we do not have the luxury of dialing in. So I say this as a core problem to solve, not only for my work and to contextualize it, but because I want people out there to hear that. We have a conference every February in Houston, IWS, which is for human space health, where people like Trish, which funded this project, is like a side arm of NASA that funds really weird and out there and quirky, cool ideas for this kind of problem. They talk about how to do this and what ideas we have, and they really love working with all kinds of other tech fields and tech people. So, if this somehow rings true to you, or you have like an amazing idea for that, you should check it out. I highly recommend it, and maybe you can contribute to something greater for out there. Okay, so yeah, we work with amazing people like Doug Ebert and Ashad Sargsyan and so on, who are experts in this field at NASA and have been for decades. And that all led to the very first mission that actually brought our app to space. So here you see the Polaris Dawn mission. It flew a few weeks ago up to space, and she is showing an ultrasound device called the butterfly probe, which I have here, because that is what we teach people in our particular game to use. It's an amazing device, which literally plugs into your phone or into a tablet. And when you then perform ultrasound on yourself or on others, it performs like a regular probe. It's the most smallest probe that we have. That's why we're using it in spaceflight. So you see her holding it right now, and it can plug into this tablet that she has. So this tablet runs our game as a companion to performing this procedure and doing it properly. The way this looks in practice is this is kind of the procedure guide. Just to give you an example, when we made this, it is interactive. It's a little short of a game, I would say, but it very specifically is trying to capture what you can really only learn from someone showing you something in person, like the little tips and tricks. So we include things like this, where in real life you would teach someone who's doing this for the first time that they can distinguish between the IJV and the carotid artery by pressing into the neck, and then one of them collapses and the other one is like staying active. We show things like little markers as companions to make sure you get the timing right. So it was our first attempt at this particular training. So this flew to space, and then we went to move on to work on Artemis, which is the one with the efficacy study. I'm only showing a small sliver of this right now to show that we've expanded the training in it a little bit to include more fundamental principles that we want people to understand when they use ultrasound, not only the step-by-step procedure memorized, which works for some of this, but if you think about Artemis as a long-term mission, when we send people to the moon and to Mars, hopefully, where they don't have access to remote guidance, then we need to solve the problem of people need to fundamentally understand how to do these procedures and why they are performed that way so they can troubleshoot them or understand how to transfer those skills to other parts, potentially, instead of just following a step-by-step guide. Because on a 2-year mission, you might need to go beyond a step-by-step procedure. You might need to apply the same skills to other things. So a lot of the work that we did on Artemis, it was about fundamental like understanding of how this works. So here we're adding an anatomy, and we're adding some knowledge that is more fundamental and transferable. I'm not showing you the fundamentals chapters here because we will play them later. Those are literally there to teach you the spatial awareness, the understanding of ultrasound, how it works in a game-based learning scenario. Okay, so this is the journey, and now we're at Explore Ultrasound, which is the platform we're building. And this is the one that we're going to play later. Now let's move on to the actual game design part. I never know what kind of audience I get, so I do put like a little bit of a definition of what game design is here. If you already know, I'm sorry. The way I like to define it for people who are a little unfamiliar, because most people think I'm a coder, which a little, but not really. What I really am is we are architects of a game systems and the user experience within those systems. So we often advocate for our players and for our users. We are the gatekeeper of their journey and progression through those systems. Our work is a lot about the rules and the playground that we create for our users. And we care a lot about their enjoyment and infusing our work with meaning and engagement to get people through the content in an enjoyable manner. And I actually believe that every experience that is made for humans in any kind of way, from a video game to a microwave, can benefit from some of this approach and from like thinking about it the way that game designers do. I also want to point out a few points that I see whenever people for the first time engage with games as an inspiration for other software. Because the easiest and to me sometimes frustrating route is for them to think about it as a simulation. So it's an easy pitch to go, oh, you have this training that you do with your whatever, how many people, and you have to like rent a facility and rent a trainer and like rent whatever kind of stuff to make it happen. Just make it into a game, and then people don't have to travel somewhere, and they understand the cost-cutting benefit of replicating real-world scenarios. But I always get frustrated with that because it often does not offer much more beyond that replica. And it misses out on the real power of video games and is lacking the imagination that I would like for people to recognize as important and useful. And quite often it's actually more expensive to make than having a better or a more imaginative approach to it. Whereas games, on the other hand, if you think about them, if you're not afraid of that term, if you're not afraid of it being like a playful experience, then you can recognize that they are about mastery and translating concepts into digestible, engaging experiences. So we very often, when we make games, have a deliberate progression curve through that content, and we are very intentional about teaching people in like a sensible manner that sticks, we have an inherent concept and value of promoting gradual mastery within the worlds that we make. And, as I said before, I believe that play and meaning are the most natural ways for any human to learn in general. Okay, so with all that being said, I do want to get into the practical part of this. I want to give you a model that you can use to think about your own software, your own applications, your own whatever you're making that will help. And there's as many methods for that as there are game designers. And I'm picking out one that wasn't done by me, but that I found to be the most valuable for people to start thinking about it that way. It's made by Daniel Cook. He wrote an article called The Chemistry of Game Design. Look it up, it's amazing. And it's basically like a skill tree approach that thinks about every single action that the player or the user needs to take to learn how to play your game or how to use your application, from button clicks to pretty much anything. And I'll give an example on how it works, and then we'll look at how we made that in Artemis. Okay, so I want you to think of an action that your player can take, a learning action if you want, and break it up into these few things. So there's a user action, Then there's an in-game or under the hood process of sorts. Then there's feedback back to the player. And then there's an updated mental model. And the lower part is really the important part here. To give you an example, like a concrete example, it would look something like this for something like Super Mario, which I hope everyone knows. I feel like it's been old enough that everyone knows what Super Mario is. So I'm hoping you understand. So this is an example of what the first action would be. One of the most important things you need to learn is jumping. So the user action here is pressing the jump button. Then there's an in-game process underneath the hood, which is jumping and colliding if applicable. And then the feedback is the animation placed for the player to observe. And the updated mental model, the important part is I can jump. Now, we do want to start chaining these things together. As an example, it would look like something like this. After I've learned jumping, I can learn the next best thing, which is I want to reach a platform. So the action, again, is jumping near a platform. The under the hood process is jumping and colliding. And then the animation playing is the feedback that the player is getting. And the updated mental model, again, it's building on top of the other one, is I can get higher by jumping onto platforms. Now, I do want to point out that the previous node here, the jumping node, has a markup here that we call model burnout. You can use this in all kinds of different ways, so there's no like fixed rules for it. I use it usually to decide when I feel like a skill has been performed enough times so I can introduce more elements. So that can be all kinds of things. It can be you need to do this 50 times or 3 times or whatever, once. Sometimes that matters. And sometimes you can use it for testing too. So there's multiple applications for that. But it's important for you to understand how these things have to relate to each other and when you can introduce new pieces. Now, for Artemis, it looks a little bit like this. And I'm sorry, I don't have the full tree. It would be too complicated to go through and too long. If you're interested in seeing it though, I have my email address in the end. And you can email me and I can send it to you so you can like have a look at how exactly it functions. But we'll also discuss it in the game we play together in a moment. So the 3 big building blocks when trying to teach someone how to use an ultrasound probe are these. There's a probe introduction over here where you have to learn what is this thing in the first place, where the beam comes from and what this beam actually does. We're teaching you a little bit about probe agnostic things such as the marker and how it relates to spatial awareness. It will make sense once we play the game. So all of that is like wrapped up in that beginning stage of the game, and then it leads into spatial reasoning. So that is really where the meat of it is coming in. The main thing you need to learn is how the probe and the object you're scanning react to one another and how they relate to one another. So understanding the spatial reasoning behind it is very important. And you'll see how we do this with puzzles in the game. And then a little bit overlapping, there's a probe manipulation part where then we don't not only want you to understand the relationship between probe and object, but also how your movement of the probe can interact with that. Okay. So I want you to kind of keep that in mind a little bit while we play. I will also point it out, but now we want to play. Let's see if I can bring this up properly or if it completely lets me down now. It does not. Wonderful. I can't like hear you, but I think the way we want to play is I will walk you through a few of these things and then we'll have a few puzzles where there will be 3 options to choose from. And I want you to pay attention and like try to solve them with me. And I'll say, okay, the first, the second, or the third, and you just raise your hand to tell me which one you think it is. Okay, we'll get to it in a moment. But I just want to point out that this is like these are the packages for the fundamentals. This is the probe intro that I mentioned, and the spatial reasoning and the probe manipulation. And then we just have a bunch of puzzles for fun. But these are the teaching principles. So I want to start by just giving you a little bit of a general idea of how we start out. We try to keep, trying to put text in there really to a minimum because no one likes to read. It's just not very fun. And, even though doctors, our target audience, loves to read, I don't particularly enjoy that. And I want to get to the interactive part as soon as possible, which is, after about 5 clicks or so. So here's what we're showing you. The first interactive part is this. We're showing you a probe. We're visualizing the beam, which obviously in real life is not visual. The way it actually functions and the way a sonogram would show up on a screen. And then we give you an object that we can just move around freely. We don't give you an objective. We just say, okay, just play around with that. And then we intrinsically learn a few things just by playing around with what we got. So we have a cylinder, but the second we move it into this beam, we see that on the left-hand side, it shows up not as a cylinder, because obviously it's a 2D object all of a sudden, which is what we want you to learn. It shows up as a rectangle. And we also visualize that by showing the top part here sliced through and cut off. So this is intrinsic learning and like contextual learning that we give you just by having you observe what you do on screen. The beam is a slice through an object. Now we reinforce that again by giving you some more. This wooden puzzle piece becomes this like U-shaped thing. The strawberry is a strawberry but sliced through, and this little turtle thing is a turtle but sliced through. So we just keep going through that. It's all contextual learning so far. Now we're adding like a little additional thing to it where we want you to understand what happens when you rotate things in the beam. So you have the ability to rotate things around. This is pretty obvious if you rotate it this way around, but the second you go and rotate this way, you suddenly see that the slice changes the object and how it shows up, not as a rectangle, but as a cube. And then we make you solve your first puzzle. In this case, very easy. Just matching this goal over here. And then again, we're reinforcing the same thing by going in and giving you the same shape on the goal sonogram, but a different object. So a rectangle and a cylinder show up the same way. This all seems obvious once you see it, but this is a fundamental thing that you need to learn. And same thing here. So now you have to be a little smart and know that you cannot create this little square with the cylinder. So you have to rotate these around and so on. Okay, so I'm not going to go into like the in-depth of all of this. I will also give you an opportunity to play in the end yourself. We'll get to that, but let's actually play together. Okay, so now we're going into the which sonogram puzzles, which are all about understanding the relationship between a probe position or the probe itself and the object. So we're giving you a series of puzzles here where there's a probe and there's an object in the beam. And you need to understand the relationship between the two to tell me which one of these sonograms it is. So have a look here. It is important to know that each probe has like a little a probe marker, which is indicated by this blue dot here. It's underneath the probe right now in this particular case, which indicates the orientation of the probe beam. Okay, so have a look at this, and I will go first, second, and third, and you will raise your hand for which one you think it is. Who thinks it is number one, the top one? Okay. Who thinks it's the second one, the middle one? Some hands. Who thinks it's the third one? Okay. Shy hands, shy hands. I think we had the most on the second one. All right, nice work. All right, let's try again. Let's try again. Let's try again. Same thing. So you see the marker here up top, and you see the stone in this beam. Who thinks it's the first sonogram? Who thinks it's the second sonogram? Who thinks it's the third sonogram? All right, all right, all right. There you go. There you go. You're getting there. You're getting there. I do want to point something out real quick, which is something that we call design negative space. So far we've been right, but if I went ahead and I now deliberately chose the wrong one, we do something very specifically, which is we show you not only that it's wrong, but we also show you where that probe would need to be to produce that particular sonogram. So here, it would need to be there to actually produce a sonogram. This is design negative space. You have to give the player or the user feedback for when they're doing something wrong and how to do better. So one more before we move on to some other puzzles. Okay, so who believes that this little heart here Is the solution is sonogram number one, the top one? Who believes it's the second one? Who believes it's the third? All right, I think we had the most at the top. Very good. Okay, let's make it a little bit harder and we'll add some additional cases that are somewhat related to spatial awareness, but a little bit harder. Same principle. Instead of choosing which sonogram it is, this time you're choosing which probe will produce the sonogram on the left. So now, same thing. You're trying to understand spatial awareness here. You'll see in a moment why this is harder. But let's do the first one. So have a look at the sonogram on the left and then the three different probes that we have here. And I will ask if it's the first probe that makes the sonogram. Who thinks it's number one? Who thinks it's number two? Okay, who thinks it's number three? Excellent. I think most people were two. Good job. Well done. Here, and this is what I want you to pay attention to. This is the sneaky part of how video games contextually teach you how to do things. One of the things that I want you to learn here as the player is that you have to start looking for landmarks. In this particular case, it's a bunch of mushrooms, and the only way for you to solve this, because all of these probes are on the same planar level, is for you to start counting and to relate it to the placement of the probe. So you intrinsically learn to start looking for landmarks. So this is a difficult one. Have a little bit of a look around here, and then we can have a look. Who believes this is probe number one? Who believes it's probe number two? Who believes it's probe number three? Okay, I think most people believe it's probe number three. I'm sorry. Close, but it's actually flipped. So again, we're doing design negative space here. Whenever you click the wrong solution, it will teach you about what it would be if it was this probe, but it is actually number two. One more, and then we'll move on to the last puzzle that we'll look at. This is the same thing. We have the same plane. We have this lovely half orange here. Who believes it is probe number one? Who believes it is probe number two? Who believes it is probe number three? All right, I think most people were for one. Excellent job. Okay, you get the gist. I'll have a link up later where you can play it yourself. Now we're talking about the last part before I'll put that up on screen. Okay, so now we've gone through the probe intro. We've taught you how to think about the beam as a slice and how objects show up in that slice. We taught you spatial awareness, the relationship between probe location and object, and how to think about that and how to look for landmarks. We're building on that knowledge now in the probe manipulation levels. So here we're giving you an opaque sphere and a probe that I can now freely move around this sphere. And we're asking you to apply all the things that we've asked you to learn so far. So I need to understand that from the probe head, there emits a beam that slices through this object and shows me what's inside. And then I need to very likely figure out how I will find out what's inside out of these three objects at the bottom. And the only way I can do that is by deciding what landmarks I want to look for beforehand. And no one explains this to you. This is just inherently by the context of you problem solving this particular puzzle. So this is an easy one, obviously, because, the shapes are very different. I'm going to ask you anyways. Who believes we're looking at a strawberry inside here? Who believes we're looking at a turtle inside? Who believes it's the wooden puzzle? All right, excellent. It is obviously the turtle. Now, this one you already can tell what's important here. So we deliberately put three very different objects here, but we want you to learn how to look for landmarks. So if I were to look for this particular object, I would look for round shapes. If I look for the wooden puzzle, I would look for, harsh edges. And if I would look for the boat, I would look for the sail. Now I have to move around the probe to see what I'm actually looking at, and I can make this very easy for you. Who thinks it's the first object? Obviously, everybody. Well done. Okay, so I intrinsically learn how to move the probe around. This is also an easy one, so I'll do this for you because I want to get to my most exciting one. This one is actually the little penguin. My favorite puzzles are these ones. They are chess pieces. And you can see why chess pieces are the perfect example for this exact problem for you to solve. Because the second you look at chess pieces from like the lower halves, you don't know what they are, how they are different. So the only way for you is to deliberately and accurately look for the landmark, which is the head of this. So I'm gonna move the probe a little bit up, trying to figure out how to get like a proper slice to the top of it, and this is what it looks like. Okay, let's see. Who thinks it's this one, the first one? Oh, I think I lost my camera. I'm sorry. Who thinks it's the first one? Who thinks it's the second one? Who thinks it's the third one? All right, you're all experts. Well done. Well done. Good job. Good job. Okay, so this is all I wanted to show you. And now I want to give you a little bit of a... Oh, my camera's back. Wonderful. I'll bring up the presentation again because I do want to give this to you so you can try it out yourselves. We have a platform called Remote Play. If you want to play the game yourselves, I have the game up for the next 24 hours for you to play yourselves on your phones, on your laptops. You can either do it through the QR code or the link that's above the QR code. It might take a little bit of time to load because our servers, we don't have a huge amount of servers in Australia, but we have one in Sydney. So maybe it works, and it depends on your network a little bit. But it will be up for the entire day and up until tomorrow. So you can maybe find some free time and play it yourself if you want. Okay, so in summary, I walked you through all these principles and I walked you through the specifics of how we build agnostic knowledge for you to understand the fundamentals of ultrasound in a game without giving you a whole lot of instruction or a lot of text to read. I hope it made a little bit more sense from how I laid out the skills here. If you're interested in the way this looks in like specifics for each specific skill, you can email me and I will send it to you. And that is the end of the presentation. I'm sorry, I'm not a huge social media person, so if you want to talk to me, it has to be through email. Or you can go to snakeos.com, which is the company I work for, and see what they do. And yeah, that's it.
All right.
Thank you for
Thank you
playing
very
a
much,
game with
Theo.
me.